Hello everyone, welcome to this KANPUR-NPTEL online course on space environment and its effect on orbital spacecrafts. So, during last few sessions, we were discussing the vacuum environment in which the satellite operates, and we discussed various issues like the extreme temperatures, then exposure to the radiation and the outgassing. In the last session, we discussed what are the specific effects when a satellite is exposed to the UV radiation. Then we discussed the design guidelines and mitigation techniques to overcome the issues with all the that is different, that is whether it is a thermovacuum environment or a radiation environment or the outgassing thing. So, all these things we three things we discussed. Today, we will start that is we will see the spacecraft environment from a different angle. So, in this few next few sessions, I will be discussing that is the spacecraft environment called the neutral environment. So, now it looks a little bit confusing when I was talking about the vacuum. Now, how the particles now come into picture, that I call it neutral particle environment or the particulate environment. So, as you remember, when I was talking about the vacuum environment, we said it is not the perfect vacuum, but instead of that it is vacuum means it is a near vacuum or hard vacuum. So, we said something like the pressure of the order of 10 to the power minus 6 or less than it, we call it a vacuum environment, where whatever these the atmospheric pressure, that is the atmosphere near the earth is capable of doing, like saving us from or this that is protecting the earth from overheating or overcooling, then protecting the earth from earth's atmosphere from the harmful radiation. So, all these things we told, but at the same time there are the particles and even that particle density is very less, that can create the problem for the spacecraft. So, we will discuss in this category, that is the neutral or the particulate environment of the spacecraft, what are the effects and what are the things we need to consider. Okay. So, in this topics we will discuss the that is the neutral gas which flow around the spacecraft, and then what are the effects on the spacecrafts. So, we will consider the effect because of the atomic oxygen. We will now say how the atomic oxygen is relevant in this and which type of orbit the atomic oxygen is relevant, and then the atomic oxygen, what are the effects. So, we will consider the sputtering, then contamination and spacecraft glow. So, we will discuss each of these three phenomena in subsequent slides. So, now what is a neutral space environment? So, the region of the spacecraft's atmosphere containing the neutral atmosphere. Neutral atmosphere means those particles you are considering which are not the charged particles, like they are not neither ions nor electrons, they are the neutral particles. So, the altitude, that is the altitude from the earth between 90 to 600 kilometer, this is known as the neutral thermosphere. So, why you call it thermosphere? Because we will see that whenever the radiation from the this is especially the solar radiations are absorbed by the particles and the temperature rises. So, this is the reason it is called the neutral thermosphere. Of course, inside this thermosphere ionosphere also comes, we will mention all those things time to time whenever it will be relevant. So, the thermosphere is composed primarily of neutral gas particles which tend to stratify based on their molecular weight. So, again it depends on what is the the gravitational pull. So, the lighter the molecules or lighter these atoms, they will be able to go higher and higher altitude. So, specifically when you go higher and higher altitudes, this density of the particles, it goes down. So, we will see that the atomic oxygen is the dominant constituent in the lower thermosphere, and with helium and hydrogen being they are the lighter materials. So, that those two elements, that is helium and hydrogen, they dominate the higher regions. So, the neutral space environment, this includes both natural as well as the man-made, and this can be macroscopics like atomic oxygen, hydrogen or the helium, or it can be the man-made macroscopic particles like. So, this microscopic particles is the atomic oxygen, and macroscopic particle like asteroids or micrometeoroids, etc. And the man-made macroscopic the environment or particulate environment, it is consisted of the objects such as the orbital debris. We will discuss in detail what are the orbital debris and what are the effects. So, what are the effects of the neutral environment on spacecraft? So, when you consider the atomic oxygen, so atomic oxygen, we will see that atomic oxygen is very active and it reacts with the material and it oxidizes, and because of this oxidation it gave rise to oxidative erosion of materials. Then it leads to spacecraft contamination. We have seen how the contamination is spacecraft contamination is done because of the outgassing. Now, we will see along with the outgassing as well as the atomic oxygen attack how the contamination happens. Then a phenomena, it is called the glow phenomena, that we will explain, that is how what is the glow phenomena and how it happens. So, this is about the atomic oxygen. Now, there is another effect which is called the atmospheric drag. So, this particle density may be very low, it is very tenuous, but still it can give significant atmospheric drag to the spacecraft, which may deorbit the spacecraft. Then the macroscopic particulate environment, especially the micrometeoroid or the satellite debris, their effect is that those can have a hypervelocity impacts on the spacecraft, and we will also see that because of those hypervelocity impacts, what happens to the spacecraft, how the spacecraft can get damaged, or there can be a depressurization in this when we are considering this spacesuit, or when we will consider this international space station. So, how atomic oxygen is formed at the upper atmosphere and how it is sustained. So, basically this the atomic oxygen is formed at the upper atmosphere, and it is formed by a process called the photodissociation of molecular oxygen. So, what is photodissociation? It is also called photolysis, photodecomposition or photofragmentation. So, this is a chemical reaction in which the molecules of the chemical compound are broken down by absorbing of light or photons. Now, here in this process, that is this in one target molecule, this dissociates into two fragments by the interaction of one or more photons. So, the light or whatever you mentioned, this is broadly defined as the radiation spanning the electromagnetic spectrum of, that is the ultraviolet light or visible or infrared regions. So, this shows that is how the atomic oxygen is. So, this is a diatomic oxygen. So, whenever this, that is the electromagnetic energy in terms of photons is incident on the, that is the oxygen molecule, so it is dissociated into atomic oxygen. So, you see this is a monoatomic, so this is single atom oxygen. It can happen with the ozone also. So, ozone you will get that is oxygen and this O2 plus O. Now, once this is dissociated, generally since this atomic oxygens are very active, so they can, the recombination can happen very soon, but we will see that in those orbital altitudes where the density is very low. So, the mean free path is very large. In that case, the recombination process is very slow, and this type of atomic oxygen can sustain at that height. And since atomic oxygens are very reactive, so these will they give rise to the phenomena like they can break the chemical bonds, on the surface of the many materials, And you know the type of the materials is used in the satellite, that is especially the hydrocarbon, that is the polymer material. So, they are very much susceptible to the oxidation by or the reaction by atomic oxygen. So, as the dominant atmospheric component of the area ranging from 200 kilometer to 800 kilometer, atomic oxygen accounts for 80% on average of the total composition in the upper atmosphere. So, you can see from this figure that you see at the earth's surface, already we mentioned and you know that this 78% of these gas constituents are the nitrogen molecule, whereas 21% is the oxygen and rest 1% is carbon dioxide and the other trace gases. But when you are going to higher and higher altitude, so you can see at 400 kilometer altitude, the constituents of atomic oxygen is 95.9%, whereas the nitrogen is 4.1%. So, that the upper when you are going upper atmosphere for 400 kilometers and above, this oxygen molecules, that is the not oxygen molecules, but that atomic oxygen that dominate. And this atomic the density of the atomic oxygen, this varies with altitude and the solar activity. We will see, because the reason for the formation of dissociation is the photon or the. So, the density of the it will vary with the solar activity, and we will see how this, what is the the relation between the atomic oxygen and the solar activity or the solar cycles. So, molecular diatomic oxygen is stable and it requires a dissociation energy greater than 5.12 electron volt for the dissociation of the diatomic oxygen to atomic oxygen. So, you can see here this H nu, this is H nu. So, H nu is greater than 5.12 electron volt, which is equivalent to that the radiation or that electromagnetic radiation of the its wavelength is of the order of 243 nanometer. So, you see this atomic molecule is getting into atomic oxygen. Now, what is this electron volt? So, you know what is the electron volt is the energy. So, I can so generally the energy I can express it charge multiplied by the potential. So, this is the energy. So, when I call it's 1 electron volt means the energy. So, 1 electron volt is the kinetic energy required to accelerate through a potential difference of 1 volt. So, I can write here the energy will be equal to. So, the charge of an electron is it is 1.6 into 10 to the power minus 19 coulomb multiplied by 1 volt. So, this is equal to 1.6 into 10 to the power minus 19 joule. So, 1 electron volt is equal to. So, 1 electron volt is equal to 1.6 into 10 to the power minus 19 joule. So, due to photo dissociation, that is oxygen exists predominantly in the atomic form. So, due to its highly reactive nature may chemically erode surfaces. So, what is erosion? Basically erosion or the sputtering. So, what it can do? It can remove the that is we will see through a schematic. So, it can remove the material or in the molecular form after the chemical reaction. So, this is called the erosion. So, because of this erosion or this sputtering, there can be some sort of chemical etching on the surface, and this changes the chemical properties of those material. So, many materials which are used in the low Earth orbit thermosphere region orbiting spacecraft surfaces are susceptible to attack by especially those polymer materials which are used as a thermal blanket, which are used as a structural material, as a protective cover. So, all these things are affected by the atomic oxygen attack. So, as I already said, the mean free path of atomic oxygen is sufficiently long. So, the probability of recombination of the formation of diametric oxygen or ozone is very small, because here the recombination rate is very slow. So, the absorption of solar radiation, it also increases the temperature of the uppermost atmosphere to about 800 degrees Celsius. So, this is the reason that is called the the thermosphere, where the temperature increases. So, the flux of atomic oxygen. So, what should be the flux at a particular altitude? This will be dependent on the following factors. First, it is the altitude. Where is the altitude? As we have seen, around 400 kilometers, it is maximum, it is coming something like 96%. Then what is the inclination of the orbits? That will also, suppose the orbit is not equatorial orbit, but is an inclined orbit, then it will change with the this flux of the atomic oxygen also with change with the latitude. Then the solar cycle. So, solar cycle means the number of sunspot cycle, or we can call it maximum to minimum. So, during the maximum there are different types of the solar activities happens, like coronal mass ejection, solar flare, solar energetic particles. So, because of these things also, because of those solar activities, that can change this, what is the flux of the atomic oxygen. So, this is the same whenever there is solar active cycle, there will be the geomagnetic disturbances, like it can be solar storm, geomagnetic storm, it can be geomagnetic storm, or soft storm. Then seasonal cycle. Seasonal cycle also, because this solar flux also it is a function of it is what is the season, because the Earth's, that is the spin axis, it is at an angle of 23.5 degree with this orbit in which it is orbiting the sun. So, because of this there is a seasonal variation of the solar illumination. So, this seasonal variation also will have an effect on the flux of atomic oxygen. Now, we will see that is how this atomic oxygen density, that is how it depends on the solar activity. So, for that this model MSIE. So, MSIE is basically mass spectrometer, incoherent scattering. So, this is basically an empirical model, where the data from these various spectrometers on board the satellite, mass spectrometers on board the satellites, as well as the ground based radars. So, whenever an RF signal is transmitted and it is intercepted by the ionosphere, what happens? The ionosphere, because it is having a different thermal energy, so it is having different velocity. So, whatever the signal is scattered by the electrons, that will be different, and it will be a random one. So, that is why it is called incoherence, means the phase as well as the frequency of the signal, it will be different. So, using those data, so a model is made, that is called the MSIE 90. So, basically it shows that is different. So, this is a solar index. I will explain what is this thing. So, you can see that at different solar index, when this is increasing means the solar that is solar activity it is going, suppose this is minimum, then this is the maximum. So, you can see how the density of the atomic oxygen is increasing from, you can see from something like 300 kilometers to and higher altitudes, how it is the density is increasing. And now, what is this F? So, this is called the solar radio flux, 10.7 centimeter. So, 10.7 centimeter, it is in wavelength. It is a wavelength corresponding to this frequency, 2800 megahertz. So, this is an indicator of solar activity. So, this 10.7 solar radio flux is also known as F 10.7. So, along with this and the sunspots number, one of the, so this is one of the most widely used indices of the solar cycle, F 10.7. Like we have seen the different types of these geomagnetic indices like Kp index, K index, DST index. So, this is a different types of indices. This is based on this model, this is MSIE model. Okay. So, this already I have written, the MSIE 90 is mass spectrometer and in current scatter model of the upper atmosphere. And now, this we will see this figure here it gives that is here we are considering that is the solar radio flux index of 150, and in that what are the density of or the concentration of the other particles like oxygen, then nitrogen, then diatomic oxygen, then helium, then argon, hydrogen, that is atomic hydrogen and the atomic nitrogen. So, you can see here that this is the atomic oxygen, this dark one is the atomic oxygen, this one is the atomic oxygen, and you can see it dominates from 175. So, somewhere here it is somewhere here. So, from somewhere 175 to 600 kilometer it dominates. Okay. Then after that other components like hydrogen or the helium, those elements they dominate after that. Now, we will see how this atomic oxygen interacts with organic surfaces. As I say, there are various organic or this polymer materials are used in the spacecraft, especially as a coating. So, you see here it is shown there is the ISS and these are the solar panels. So, there are the protective covers. So, protective covers it is made of those organic surfaces or the polymer surfaces. So, this is one polymer surface. So, what happens because of the UV radiation, that is this diatomic oxygen present at that altitude of ISS like something like 400 kilometers. So, it dissociates, that is the after dissociation you get this atomic oxygen. Now, this atomic oxygen when it impacts the surface, what happens? It sputters the there is the chemical reaction. So, what you get? You get OH and then it can be this because it is a hydrocarbon. So, you will get this compound OH or it can be CO or CO2. So, this is called the sputtering. So, this is the way the atomic oxygen interacts with the organic surfaces. So, we have seen that atomic oxygen is very reactive and energetic enough to break chemical bonds in materials. And what it does? This the reaction products with polymers and carbon containing materials volatile. So, that can create this is from like carbon monoxide or carbon dioxide. Also, the metals and inorganic experiences surface oxidation in some cases leading to shrinkage or cracking or spalling. Atomic oxygen also can thermalize on contact and scatter from surfaces leading to further reaction, which is dependent on the materials it contacts and the geometry and sometimes lead to spacecraft glow. We will see what is spacecraft glow. So, the effect of atomic oxygen has on a particular material on a spacecraft is dependent upon how much is the intensity or the density of the atomic oxygen arrives at the surface, what is its energy, and it can be affected by mechanical loading, temperature and other components in the environment. So, this is the way it affects, it depends on so many parameters. So, again atomic oxygen generally causes surface reaction, but it can scatter under coatings as well as into crevices. Crevices means those maybe some defects or maybe some undulation. So, what they do, this causes oxidation much further into the spacecraft surface. So, because of those crevices or can be some undercoating, so they can go much inside the surface, and the structure, then the structure would have aspected if those things were not there, under coatings and the crevices. So, contamination is generally caused by the arrival of the volatile species that condense on the spacecraft surfaces. So, as you have seen, that is how this outgassing and this happens. So, the volatiles are typically the result of the outgassing material, that already we have seen in the last module. So, what happens, those outgassed materials when it is condensed on a surface, then that can be fixed on the surface by ultraviolet radiation or atomic oxygen reaction to form a stable surface contaminants that can change the optical and the thermal properties of materials in the power system, thermal system. So, we have seen both the outgassing as well as the ultraviolet as well as the atomic oxygen. So, these three can give rise to really the contamination. So, it can contaminate the lenses of a camera. So, those contamination, this can cause the detrimental changes in optical and the thermal properties. So, this again each situation is unique, and for accurate prediction of the degradation of a material or component, generally it should be tested or it should be modeled in the configuration representative of how it will be used in the spacecraft. So, next we will see what is spacecraft glow. So, generally because of those sputtering and because of the high energy, there is a sputtering of that is in the form of the gas, which are originated just immediately above these surfaces, and which face the ram direction. Ram direction means the direction in which the vehicle is moving. So, the spacecraft or the space shuttle in orbits at the altitude of 250 to 300 kilometers fly, they fly through thin gases at a velocity of 8 kilometer per second, which causes the air rush to past the spacecraft, and because of this type of, that is this shows it is during this sunlight. So, this is a picture when the sun is. So, this is at night. So, it is shown that here you can see, if you compare these two, there is some there is in the REM side of the spacecraft, it can show there is some the glowing, it is as if it is. So, this is called the spacecraft glow. So, this is called, from the spacecraft a strong wind seems to be blowing, analogous to the wind that person might feel when he is putting a hand on the window of his. So, this impacts of this wind on the shuttle surface gives rise to two remarkable phenomena. So, one is the spacecraft glow in orbit, and its body is slowly eroded away. So, already we have seen how the erosion happens, and the faint glow surrounding the shuttle. So, this is the result of the nitrogen in its thermal cladding reacting with the oxygen in the very thin atmosphere in a low earth orbit. So, this is called the atomic, that is called the spacecraft glow because of the atomic oxygen effects. So, just I will conclude here today. We discussed this neutral particle environment and its different effects, that is that especially the atomic oxygen attack like the erosion, then spacecraft glow, and in the next class. So, we will see that is how it leads this particle leads to the it is called the atmospheric drag. So, thank you very much.